All right, let's talk about concavity. So concavity is sort of just a fancy word for like curvature. How curvy is my graph, okay? And so based on that, there's some definitions about being concave upward or concave downward. You probably have dealt with this mostly in regards to parabolas, and parabolas only have one type of concavity because they're either curved, so that way they're like curved upward, or curved downward, so we call those concave upward or concave downward. But polynomial graphs and a lot of other graphs, they change concavity constantly. So like, what's a firm definition of being concave upward versus concave downward? Well, the best definition you can come up with that doesn't get too into calculus is concave upward is when the slope is increasing. And so that implies sort of like instantaneous slope, or the tangent line's slope is increasing as you're going along. And then concave downward would be when the slope is decreasing. So like if you have like a not so steep slope, but then as you sort of move along, the slope gets steeper and steeper and steeper, then that would be concave upward. But if maybe it's not so steep, but then it starts to flatten out to zero and then become like a negative slope, that would be decreasing. So here's a graph that has some various things going on with it in terms of concavity. So let's take a look at each of the little intervals. It's chunked it up for us, so that way we can sort of see the different changes in concavity. And so what is the concavity in the first interval here from A to B? Well, let's take a look. What I like to do is sort of think about the tangent lines along the curve here. So like at this point close to A, there's my slope. And then as we sort of move towards B, and I keep changing my slope, I notice that, well, that slope is getting less steep. In fact, at some point here, it's going to have a horizontal tangent line and then turn over into a negative slope. So because of that, it's going from over here towards A, a pretty positive slope, to as it approaches B, it's over here as a negative slope. Going from positive to negative would indicate that that is a decrease in our slope. So this is concave downward in this interval. CD for short. Okay, well, let's do the same thing for the next interval from B to C. So again, like I can see here, that's my slope is negative, but then as we move along here, it flattens out and turns over to the positive side. So over here near C, our slope is positive. So to go from negative to positive would be an increase. That would mean we are talking about concave upward. Take a moment to see if you can identify what the next four intervals would be, concave upward or concave downward. I'll give you 30 seconds to think about it. Okay, that was about 30 seconds, so let's go over that. So in this one here, we have positive slope, but as we move towards D, it starts to level off and almost is probably approaching zero as we get there. So going from positive to almost zero would be a decrease, so we are concave downward. Here, very steep negative slope near D, and then it levels off and goes to a positive slope, so that would be concave upward since it's increasing. And then here, pretty steep negative slope, but then starts leveling off to zero-ish, so that would be concave upward again. So concave upward to concave upward, that sort of debunks the idea that maybe it just oscillates back and forth, back and forth. It's not the case. Notice that there's a cusp right here. That's why that happened. And then here, almost a zero slope, and then a very negative slope here towards Q, so this is decreasing, meaning this is concave downward. Excellent. So there's one more definition we need to talk about here when it comes to concavity. So there's something called an inflection point. An inflection point is the point on a graph where concavity changes. So either from concave upward to downward or downward to upward. Doesn't matter which direction it's changing in. It's just called an inflection point. So we have on here several inflection points. At point B, that is an inflection point. Point C, also an inflection point, upward to downward. Point D, downward to upward. Not this point, because it goes from upward to upward, so it did not change concavity. So not an inflection point. But then point P is, since it goes from concave upward to concave downward. So what we want to do is we want to figure out these intervals of concave upward or downward and inflection points using our calculus. The key here is to think about that we're using the same language that we were using before, increasing and decreasing. We've done plenty of things where we found intervals where a function is increasing or decreasing. This time we're not interested in the functions increasing or decreasing, we're interested in the slope increasing. Well, the slope is f prime. So in other words, we want to know where is f prime increasing? Or where is f prime decreasing? So if we sort of put on our hat here, if we wanted to know when f was increasing, we found f prime. Now we want to know when is f prime increasing. This is going to require us to find the derivative of f prime or f double prime. So that's the key to unlocking this. F double prime will tell us how is the slope changing. Is the slope increasing or decreasing? And then that tells us whether the function is concave upward or concave downward. So let's do an example of that. So let's start with a function f of x equals x to the fourth minus 4x cubed. All right, and so we want to find where this function is concave upward and downward, and then we want to find any inflection points that it might have. So step one, find the derivative, f of x. So f prime of x is going to be 4x cubed minus 12x squared. Cool. Step two now, find f double prime, the second derivative, because that's where we're going to find information about concavity. This will tell us how is f prime changing. Is it f prime increasing or decreasing? F double prime will tell us that. So that's 12x squared minus 24x. So f prime will be positive when f double prime is increasing, which is where f will be concave upward. If you didn't follow that at the very end, I sort of make a little chart here that'll sort of explain all that. So we want to do sign analysis on f double prime. So first let's figure out when is f double prime 0 and when is it undefined. So f double prime equals 0. So 0 equals 12x squared minus 24x. Common factor there, so I'll factor that out. That's 12x times, and it leaves behind x minus 2. So my zeros for f double prime are 0 and 2. F double prime undefined. Well, it's a polynomial, so never. But remember, we're sort of keeping this in mind because next semester we're going to deal with crazier things that have lots of undefined places. Okay, so now let's do our sign analysis. So we can break up our interval from negative infinity to 0, from 0 to 2, and then from 2 to positive infinity. Okay. And then what are our factors? Well, I was able to factor it into 12x times x minus 2, and that builds f double prime. What I'm also going to do is extend my chart here to have f prime and then f. So that way I can sort of show you, like, when f double prime is this, these are the things you can conclude about f prime and f. All right, so let's do our sign analysis. So 12x, well, if 12x in the negatives is negative, but then over in the positives it remains positive. X minus 2, so like negative 4 minus 2 would be a negative, 1 minus 2 would be a negative, but then after that it's positive. Include, a negative times a negative is a positive. Negative times a positive is a negative. Positive, positive. Okay, positive. Okay, so f prime is positive. What does that mean? That means f double prime is positive. F prime is increasing. If f prime is increasing, that must mean f is concave upward by the definition. So we're just trying to figure out when is f prime increasing and decreasing. That tells us when f is concave upward or downward. Okay, from 0 to 2, it's negative. That means f prime is decreasing. I said it earlier. From 0 to 2, f double prime is negative, so f prime is decreasing. That means f is concave downward. F prime negative, f double prime negative, f prime decreasing, f concave downward. Over here, if f double prime is positive, once again we are increasing for f prime, which means that f is concave upward. So let's write our final result here. So f is concave upward on negative infinity to 0 and 2 to positive infinity. F is concave downward on 0 to 2. And then lastly, inflection points. Inflection points at, well, the first place is at 0, comma, well, if I plug in 0 over to here, f of 0 is, I'm going to do some side work, f of 0 equals 0 minus 0. So 0. And at 2, comma, f of 2 is going to be, it's 16 minus 32, which is negative 16. And there you have it. That is our final recording. I totally think that the volume cut out on me, so I hope you were able to follow along if you cannot hear me.